Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use the concepts of differentiability to solve this problem. So as per the problem, state the domain on which function f is differentiable. So we have to analyze these 6 given graphs. So let's start with the first one on the top left. So here, this graph has a corner point at x equals -2. Now we know that function is not differentiable at a corner point, at a cusp, or a point where there is a vertical tangent, or a point where the function is discontinuous. So that means this function is differentiable at all x values except at x equals -2, because at that x value the graph has a corner point. So we can write the domain for this function in interval notation as -infinity to -2 union, then -2 to positive infinity. So this is the domain on which this function is differentiable. Now in the other notation, we can write the domain as xer, and x cannot be equal to -2. So we are done with the first graph. Now we can analyze the second graph. Now this graph has a discontinuity at x equals 2. There is a vertical asymptote. So for this function, the domain on which this function is differentiable can be written as, so in interval notation, we can write it as -infinity to 2. So 2 is not included in the domain, so that's why we are using the parentheses, then union 2 to infinity. And in the other notation, we can write it as xer, and x is not equal to 2. Now we can analyze the third graph. Now the third graph is a continuous function. There is no break of any kind. There is no corner point. There is no cusp. There is no vertical tangent at any point. So that means this function is differentiable for all x values. So the domain can be written in interval notation as -infinity to positive infinity. Or in the other notation, we can just write the domain as xer. So x can be any real number for differentiability of this function. Now we can analyze this one here, the bottom left corner. So now this graph has a cusp at x equals 1. So at that point, this function is not differentiable. So therefore, the domain for this function for differentiability can be written in interval notation as -infinity to 1, then union, then 1 to positive infinity. And in the other notation, we can write it as xer, and x cannot be equal to 1. So now we can analyze the next graph. The next graph is a straight line. So there is no discontinuity, there is no cusp, corner point, or a vertical tangent. So in this case, this function is differentiable at all x values. So therefore, the domain in interval notation can be written as -infinity to positive infinity. And in the other notation, we can write it as just xer. So now we can analyze the last graph. Now this graph starts at x equals 2 and only goes to the right side of 2. So that means this function is only differentiable at x values starting from 2 to the right side. In this case, there is no discontinuity, there is no vertical tangent, but there is a corner point at x equals 2 because that's where the graph starts. So in this case, the domain in interval notation can be written as 2 to infinity. So there's a very important concept we need to keep in mind. So 2 is not part of the solution. And in the other notation, we can write it as XER and x is greater than 2. Because at point 2, the function is not differentiable because it's a corner point. So if you find this video useful, please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.